Well, it's been 20 years since a telescope called the X-Ray Multimirror Mission started orbiting in space. And while it's responsible for generating 450 PhDs, 250,000 citations and making over 500,000 astronomical object discoveries, hardly anyone's heard of it.
Well, to change that, we're joined now by Warwick Holmes, who's an Avionics Systems Engineer for the Galileo Navigation Satellite Network. Good to see you, Warwick. Thanks for coming in. Now, you helped build this X-ray telescope over 20 years ago. What was it like to be part of that?
Well, this is the largest scientific mission that the European Space Agency had attempted at this stage. And it's an 11-metre long telescope which can look at only X-rays. Now, the reason this is so unusual is that X-ray light can't be seen by humans. So as soon as they launched this and turned it on, every single point in the sky that they pointed at, they were seeing 20 or 30 X-ray astronomical objects that had never been seen before. And these include galaxies, which emit only X-ray light, on the furthest extent of our universe. They could see all sorts of amazing different objects which had never been seen before. So, for example, we can look at the filament structure of our furthest of the universe in X-ray light, and we can see solar flares reflecting off Jupiter from the far side of the sun.
We're just seeing some vision here, Warwick, of the team that was responsible for putting this together. I'm not sure if we can see a flash of you
this
there
video was taken 25 years ago, so you won't recognise me, but yes, that's me there.
So
anyway, this is the building.
What was it originally tasked with, Warwick? Was it just go forth and explore, or were there some objectives?
Well, they realised that astronomers have known for many years that the stars are emitting light in all manner of frequencies, infrared and ultraviolet and X-ray, but as humans we can only see the optical. So Hubble, which is of course very famous, is taking images principally in optical light only. And so they're very familiar objects for us. So we look at the Andromeda galaxy, for example, and we see the big spiral shape, and we're familiar with that. In X-ray light, the Andromeda galaxy is completely different. And this is part of the reason why people don't know about the mission. Because if I was to show you an X-ray image of the Andromeda, you wouldn't recognise, and it won't mean very much. For scientists, it has an enormous amount of information. We can see, for example, the black hole at the centre of that galaxy. And the weirdest discovery of all was that we found that some galaxies have these black holes that they pulse every 9 hours, and they increase their luminosity by a factor of 100. So imagine if you go outside and the sun suddenly gets 100 times brighter every 9 hours. You know, for humans, this is bizarre, because we think of the universe as being very stable and the stars don't change. In X-ray light, crazy things are happening on very short timescales, which we've never seen before, because in the optical frequencies, we don't see that. So it's a very strange field of astronomy.
And Australia's been key to this, because a lot of the images came via Australia.
Absolutely correct. In Perth, there was a ground station called Nangara, which was operated by the European Space Agency. And for 15 years, 50% of all the images came via Australia, and that's now been transferred to a dish called New Norcia. So it's another one of these dish stories where Australia's had a huge role in supporting these missions, getting the images, and nobody knows about it. So there's a huge celebration in Madrid this last week. Hundreds of scientists, hundreds of engineers all came together to celebrate this 20 years of continuous operation. I just want Australia to know that we had a huge part of that story in getting 50% of all the images which the scientists are now using.
So why do we know so little about this, where you likened it to the Hubble before? Everyone seems to know about that, but not many people seem to know about this or our involvement.
Look, Kath, it's a very good question. I think it's just a question of, in this case, the European Space Agency doesn't spend much money on its publicity. It's a bit like this Quiet Achiever story.
Well, Hubble.
Hubble is with NASA, of course. So, and they do spend a lot of money engaging with the public. But for ESA, it's more about getting the science to the scientists and making it very cost effective. But so I'm sort of doing their publicity, I guess. But it's just that I've seen so much amazing data come out of this telescope. And so few people are aware of the amazing discoveries. So.
What's next for the telescope? Is it still going strong?
Well, the amazing thing, we can't kill this thing, right? It was designed for 5 years. It's been running for 20. And it's now going to go for another 10 years. So they're able to extend the fuel usage.
So it's built well done.
The electronics, not one single unit has failed. And this is what's so unusual about this mission. It's just like a Goldilocks mission. I don't know if that's the right word, but it's just an amazing, reliable...
If it's Goldilocks, it's just right, which by the sounds of things
it's just right.
All right, well, great to talk to you, and we'll look forward to the trajectory. If you said it's another 10 years, we'll be old and grey by then.
I'll come back in 10 years.
Warwick Holmes, great to see you. Thank you.
Thank you very much. Thank you.